Most people have issues with this particular aspect in terms of how to interpret the model summary, how to interpret the coefficient, and every output you get when you carry out a regression analysis. In today's tutorial, I'm going to show you how to interpret regression results in SPSS using a real-life example. To carry out the regression analysis in SPSS, go to Analyze, under Regression, click on Linear. Choose the dependent variable. The dependent variable is the outcome we are trying to predict. Move it under the dependent, and the independent variables here are the predictors. If you understand clearly what I just said, the dependent variable is the output you are trying to predict. So we are trying to predict the job performance based on the training hours, the years of experience, and the workload of the employees. Ensure your method is enter. Press your OK. This is the output result of the regression analysis. The first table you can see here is the model summary. Variable you need to interpret here is the R square. R square is the percentage of variation in your dependent variable, in this case, which is the job performance, by the predictors. R square is 0.016, and this is interpreted as 16%, which means that 16% of the changes in job performance can be explained by the workload, the years of experience, and the training hours. The next table here is the ANOVA. The ANOVA shows us if our regression in its entirety is significant or not, and here you can see that the significant value is greater than 0.05. Moving forward to the coefficient table, the unstandardized B tells us that for every 1 unit increase in the predictors, the dependent variable changes by B units. For example, the unstandardized B value of the training hours is 0.075. If training hours increase by 1 hour, the job performance also increases by 0.075 units, holding other variables constant. The standardized coefficient beta tells us which predictor has the stronger effect on the dependent variable, which is the job performance. The bigger the value, the stronger the effect, and we can see here that the training hours has a value of 0.047 while others have negative value. So this is telling us that the training hours has a stronger effect on the job performance. The next interpretation in regression analysis is the significant value. If this value is less than 0.05, that means the particular independent variable is a significant predictor. If the significant value is greater than 0.05, that means that the independent variable is an insignificant predictor. Here, the significant value of all three predictors are greater than 0.05, which means that the three predictors do not significantly contribute to this model. And just as you can see in our ANOVA results, the last interpretation to give here in the regression analysis results is positive or negative relationship. A positive B means that as the predictor increases, the dependent variable also increases, while a negative B means that as the predictor increases, the dependent variable decreases. And just as you can see here, the training hours is positive, which means that as the training hours is increasing, the job performance is also increasing. And the years of experience here is negative, which is telling us that as the years of experience is increasing, the job performance level is decreasing, the same way as the workload. As the workload is increasing, the job performance level is decreasing. Now, let me show you how to do the chapter 4 interpretation of this regression analysis. First off, open a new Word document. Once you've opened that, come back under your output and copy every of the tables. Press down your Ctrl Shift and copy. Then right click and click on copy. Inside the Word document, you want to write chapter 4 results. You want to change this to Time Name Roman except stated otherwise in your institution. Then you want to indicate the type of analysis you've done, which is regression analysis. Now paste in each of the tables. You want to format this. So you can notice the font colors are not all black. You want to highlight it and change it to black. Under the font color, change it to automatic. Yes, once you've done this, now to do the interpretation underneath here, now you write linear regression analysis was conducted to examine the effects of the training hours, years of experience, and workload on employee job performance. Full stop. The model explained. You want to check the percentage again. 16%, right? 16% of the variance in job performance, and then you open a bracket, write your R square, which is equal to 0.016. Let's check again to confirm. Yes, it's your comma. Result shows that training hours, here you are reporting this coefficient value, which is the unstandardized, and also the p-value, which is 0.724. The next one, years of experience, also do the same, and the last one, which is the workload, were not statistically significant predictors of the job performance. There is no enough data to carry out analysis. Once you've done this, you also don't want to make the error of interpreting or making any conclusion by saying that because the training hours is positive and the beta, so you want to start writing that for every one increase in the training hours, there is increase in job performance. You don't want to draw that conclusion because it is not statistically significant. But assuming that the training hours is statistically significant, then you can impute the interpretation here that for every one increase in the job performance in the training hours, there is increase in the job performance. But that cannot be stated because this is not statistically significant. With this, you can interpret your regression results like a pro. Thank you so much for watching. Don't forget to like, subscribe, and turn on the notifications button for upcoming videos. See you in the next one. Bye.